Imagine looking at the horizon and seeing the sunrise sitting halfway up the sky. NASA has released images of a never-before-seen phenomenon when the star Betelgeuse blew its top, ejecting a large portion of its surface mass. The event is known as a solar mass ejection, and according to the Space Agency, the solar flare has a mass 400 billion times that of our Sun. Scientists said it was a depiction of stellar evolution in real time, with an exploding star tearing off large parts of its physical form, surprising many. The violent explosion of this red giant will challenge much of our understanding of the universe. Why did Betelgeuse explode and how will it affect Earth? Let us know. Many constellations are arranged based on myths and legends. It is still used for navigation today. One of these stars, Betelgeuse, is among the largest and brightest stars in our night sky. Betelgeuse is the bright, reddish-brown star on the right shoulder of the winter constellation Orion. At a closer look, astronomers realize that it's a pulsating monster with 400 suns beating around the clock. Because of its distinctive red-orange color, Betelgeuse is easy to recognize and is good for convincing skeptics that stars are different colors. This star is also known as Alpha Hunter and is the second brightest star in the constellation after the blue giant Rigel. Betelgeuse's size, brightness, and red color make it a beautiful stargazer. Although the so-called alpha stars are the brightest in their constellation, Betelgeuse holds the title even though Rigel is brighter. Betelgeuse is one of the famous stars that influenced the name of the person and the movie Beetlejuice. It is the 7th brightest star from North America, Europe, and Canada, and the 10th brightest star. Earth is very close to Betelgeuse, but astronomers estimate that it is between 430 and 724 light-years away. Betelgeuse is the closest red giant to Earth in our galaxy, one of only 200 known red dwarfs. If Betelgeuse were to replace our Sun in the solar system, it would extend beyond the asteroid belt, possibly beyond Jupiter. Earth, Mars, Venus, and Mercury will be completely eclipsed by its large radius. Betelgeuse is 616 times the radius of the Sun and 16,128 times its mass. The Sun has a mass of 126,000 and a surface temperature of 3,600 K. Colder than the Sun, only about 13% of Betelgeuse's energy is visible light. If the human eye could see all wavelengths of light, Betelgeuse would surpass Sirius as the brightest star in the night sky. Betelgeuse loses about 1 solar mass every 10,000 years. The nebula is surrounded by a nebula, due to the inexorable ejection of material from the star in all directions, forming a cloud 250 times larger than the star itself. Our Sun sometimes ejects small objects into space known as coronal mass ejections, CMEs. However, the recent discovery of a large surface mass ejection from Betelgeuse sheds light on a remarkable phenomenon that occurred in 2019. The material ejected by Betelgeuse explodes into space, cooling it and creating a cloud of dust in the sky that obscures the brightness for observers on Earth. Since then, Betelgeuse's 400-day cycle has been broken. This CME from Betelgeuse released 400 billion times more mass than a typical CME from our Sun, shaking the star like a bowl of gelatin. According to NASA, the internal chambers of Betelgeuse may have been damaged, and the photo is trying to regenerate. For the past 200 years, astronomers have tracked its constant pulse, but now Betelgeuse's familiar pattern has disappeared. Most stars are formed by nuclear fusion, but as the star ages, it burns through its own fuel and undergoes several changes before dying. When hydrogen is used up, stars fuse helium, carbon is formed, and iron ends. When iron begins to fuse, the star collapses, causing a supernova explosion, one of the most powerful forces in the universe. Supernovae can release more than 10 billion suns of energy. Interestingly, Betelgeuse has changed color over the centuries. Ancient Chinese astronomers called it yellow, while the Greek scientist Ptolemy called it red. These changes may indicate that Betelgeuse is a yellow superman. Observing the mass ejection of a modern star allows astronomers to study the final stages of red supergiants and how they lose mass before exploding into a supernova. NASA's Hubble Space Telescope revealed that Betelgeuse's explosion ejected millions of kilometers of material and cooled it into a cloud of dust that dimmed its brightness. Despite the massive explosion, astronomers don't have a definitive answer as to when Betelgeuse will go supernova. It may happen in 100,000 years or tomorrow. No one can say. One thing is certain. When Betelgeuse explodes, it will not harm the Earth, because it is so far away that it will cause serious damage. However, this supernova will light up the night sky and provide a spectacular view of the entire Earth. Astronomers will continue to study Betelgeuse, but for now the mystery of its imminent explosion remains unknown. When Betelgeuse finally goes supernova, the explosion is so powerful that it can be seen even during the day, and the moon shines overhead for weeks and casts a huge shadow at night. This is a once-in-a-lifetime event, as supernovae are rare in our galaxy. The last recorded supernova in the Milky Way was observed more than 400 years ago in 1604 by the famous astronomer Johannes Kepler. But supernovae aren't just spectacular light shows. It is essential to the creation of the universe as we know it. When stars explode, elements like carbon, oxygen, and iron, the building blocks of planets, moons, and life itself, are scattered into space. Our own bodies contain elements that were formed in the hearts of ancient stars that exploded billions of years ago. In that sense, we are made of wonderful things. Betelgeuse is a red supergiant, which means it is in the final stages of its life cycle. It is too old to produce helium or hydrogen, and is now burning with heavier elements like carbon and oxygen. When it finally starts to melt the iron in the core, there is no going back. The combination of steel does not provide strength. In fact, it consumes it, and the core collapses under its own weight. The star is ejected in a supernova explosion. What remains after the explosion depends on the mass of the star's core. If the mass is large enough, the core will fall into a black hole, a region of space with so much energy that no light can be emitted. In fact, when a neutron star is formed, a very dense object made almost entirely of neutrons, a teaspoon of the substance weighs 1 billion tons on Earth. The exact nature of Betelgeuse's future remains unclear, but one thing is clear. The impending supernova will be one of the most visible and studied events in the history of the planet. Scientists hope to learn more about the life cycle of massive stars, the mechanics of supernova explosions, and the formation of neutron stars and black holes. What if Betelgeuse goes supernova tomorrow? Will there be effects beyond the spectacular light show on Earth? The good news is that Betelgeuse is a nearby planet, far enough away that its explosion would not pose a direct threat to our planet. When stars explode, they emit intense radiation in the form of gamma rays and cosmic rays, but Betelgeuse is more than 600 light-years away. Astronomers calculate that a supernova would have to be within 50 light-years of Earth to cause enough damage to the atmosphere and life on it. But if Betelgeuse explodes, scientists will have a rare opportunity to study the supernova's impact on its surroundings in real time. This explosion can send shock waves into the surrounding space and interact with nearby gas clouds, possibly forming new stars. This process is known as triggered star formation, and it's one of the ways new stars are born in the universe. Despite all of this excitement, Betelgeuse's recent mass ejection doesn't necessarily mean a supernova is imminent. Stars in their final stages can behave unpredictably, and Betelgeuse could continue its slow decline for thousands of years before finally exploding. In fact, the dimming event in 2019, which many initially thought might signal an imminent supernova, turned out to be caused by a giant dust cloud formed from material ejected by the star, not a precursor to a supernova. Astronomers will continue to watch Betelgeuse closely, using telescopes like Hubble, the James Webb Space Telescope, and other ground-based observatories. These observations will help unravel the mysteries of red giants and their destruction, and ultimately, we will understand the life cycle of giant stars and their role in creating the universe. So, while the fate of Betelgeuse is uncertain, one thing is certain. When it finally explodes, it will be a massive event, lighting up the sky and putting us in the front row for one of the most powerful aspects of history. In the world until then, we can only watch, wait, and marvel at the wonders of the world before our eyes.